everyone. Today we'll go over some practice problems for energy. Starting off, a 2 kilogram ball is dropped from rest at a height of 10 meters. Calculate the speed of the ball just before it hits the ground. So to do this, let's use the conservation of energy equation. This states that the initial potential energy plus the initial kinetic energy is equal to final kinetic energy and potential energy. Since the ball starts from rest, we know that its velocity starts at zero, meaning it has no kinetic energy at the start. And just before the ball hits the ground, it'll have no potential energy remaining because it'll be at a height of just about zero. So that means that the final potential energy is equal to zero. So we can rewrite this equation. Now that we know our initial potential energy must be equal to the final kinetic energy. So now let's calculate both of these. The initial potential energy is equal to the mass times the acceleration due to gravity times by the height. That'll be equal to the final kinetic energy, which will be equal to 1/2 the mass times the velocity squared. So through this, we'll be able to solve for the velocity of the ball just before it hits the ground. Now, we can rearrange this formula to solve for velocity. By doing so, we get that 2 times the gravity times the height, and the square root of it is equal to the velocity. Now, let us plug in these values that we have. So we get that the square root of 2 times it by 9.81 meters a second squared times it by 10 meters is equal to the velocity. And we get that the final velocity is equal to about 14 meters a second. Next, a pendulum ball moves with speed 2 meters a second at its lowest point. What is the highest point reached by the pendulum bob? We can write down the conservation of energy equation, stating that the initial potential energy plus the initial kinetic energy is equal to the final potential energy plus the final kinetic energy. Now, let the lowest point represent its initial energies and the highest point represent its final energies. At its lowest point, we can assume that there is no potential energy because it won't be able to travel any lower. It'll be at its lowest point. So effectively, we'll have no height. Whereas we have the opposite at its highest point. It'll have only potential energy and no kinetic energy because it'll have no velocity at the highest point. So rearranging this equation, the law of conservation of energy, we see that we have the initial kinetic energy, or the kinetic energy at the lowest point, is simply equal to the potential energy at its highest point. This is equal to 1/2 mass times the initial velocity squared is equal to the mass times gravity times height. You might have noticed that we're not given the mass of the pendulum bob in this equation. That's because the masses here will cancel out, so we won't actually need it to solve for the height. So let us rearrange this equation to solve for the height, since that'll be at its maximum point. By doing so, we're left with 1/2 the velocity squared divided by gravity is equal to its height. So let's plug in the values and solve for our answer. So we have 1/2 times by 2 meters a second squared multiplied by 1 over 9.81 meters a second squared is equal to the maximum height. This gives us the maximum height of 0.204 meters. A 10-kilogram object is raised 2 meters vertically above the ground. Calculate the work done on the object. So work is equal to the force times distance times it by the cosine of any angle. We see that is raised vertically above the ground, so we don't need to worry about angles, meaning that work in this case is equal to the force times distance. Now, if you raise an object above the ground, the forces acting against it will be gravity. So the force will be gravity in this case, and the distance will be the height, which is equal to 2 meters. So now let's calculate the force of gravity on the object. Since this is on Earth, we can just use this simple formula that the force of gravity is equal to the mass times the acceleration due to gravity. So then this is equal to 10 kilograms multiplied by 9.81 meters a second squared, equaling 98.1 newtons. So then the work done on the object is just equal to 98.1 newtons multiplied by the 2 meters that the force was applied on. And this is equal to 196.2 joules.